Very warm welcome to our session on AI, ML, robotics, and generative AI tools for utilities. This session aims to explore the opportunities as well as the challenges of AI, ML, robotics, and the fast emerging generative AI tools in the utility industry. We are very pleased to welcome and invite on stage our session chair and moderator, Mr. Anant Venkateshwaran, Director Hitachi Energy. A very warm welcome to you. Please join me in extending a very warm welcome to him. And joining us virtually is Mr. Amit Kumar Pandey, who will be giving the theme presentation and he's a Chief Robotics and AI Officer from Revival, France. As I mentioned, he'll be joining us virtually. And now I'd like to invite our speakers who have joined us. Mr. Luciano Martini, Chair Executive Committee from ISKCON, Mr. Sanjay Prasad, Chief Information Officer from CSC Limited, Mr. Preetham Pupuri, Business Development Manager, Public Sector, Amazon Internet Service Private Limited, Mr. Sumit Gupta, CEO, Asset Plus, Mr. Pranav Raikote, AI Researcher, Flexpo, Mr. Nitin Tanwar, Founder and CEO of Climate Connect Digital. And last but not least, we have with us Mr. Khurshid Khan, DGM IT from BSES. Ladies and gentlemen, please join me extending a very warm and hearty welcome to our eminent panel of speakers here. So without any further ado, I'd like to hand it over to Session Chair and Moderator to kindly make his opening remarks and moderate this session, taking it forward. Over to you.
Thank you so much for that very kind introduction. The session is titled AI, ML, Robotics and Generative AI Tools for Utilities. But I'd like to take a step back. I've always believed that we live in an industry where we go from the challenge of the day to the challenge of the day, of tomorrow, right? Very often we feel like we are in a constant state of change, where every day the challenge changes. That is the only constant, right? And so if you look at the greatest challenge facing the industry today, yes, there are operational challenges. Yes, there are technical challenges. Yes, there are regulatory challenges. Yes, there are policy challenges. There is a whole plethora of challenges across the value chain as India and other countries set on this path of energy transition, going towards net zero. But the challenge of today is what? Supply chain, right? Without doubt. If you ask most people, I think India is slightly better off because we have manufacturing here. But if you look at the average utility head, a CEO, the challenge is, where am I going to get my transformer? It's power transformers, you don't get them in a shop. Where am I going to get my distribution transformer? 3 years away. Where am I going to get my breakers? I keep them stocked, but the stock is, the manufacturers and the vendors are giving it 3 years away. So let's look at this for a second in terms of supply chain and see how, this challenge has emerged. And why am I mentioning supply chain? Because if you look at learning from other industries, including AI and ML applications, right? If you look at Walmart, for a simple example, if you look at the way the model works at Walmart, leveraging intelligence, AI and ML, how does it work? The Walmart aisle is owned by a cereal manufacturer. The cereal manufacturer puts cereal on the aisle, and the cereal manufacturer doesn't get paid until the cereal leaves that aisle, and you buy the cereal and walk away. When UPS supply chain decided to go from fully manual to fully automated, I was a chief architect. And what was the goal there? Was to leverage the latest and greatest intelligence technology and business intelligence to make sure not only that packages arrived on time and reached their destinations on time, but you could track real time where these packages are going, right? So the supply chain challenge, I believe, can be solved and can be made a lot more easier leveraging AI and ML technologies. I do genuinely believe that. Now, having said that, there are other challenges that we will come back to, right? The traditional challenges that we often talk about. Across the value chain, when you look at from a utility perspective, and in the state of energy transition, you have generation, you still have, the generation gets distributed, but you still have generation, but now the generation is variable. So AI, ML technologies are being leveraged and used to predict and forecast the generation patterns, solar, wind, and see how and when will be the times when the utility can depend on the solar generation, right, or the wind. Then you have transmission and distribution, but before you even come to distribution, you have transmission, and there's this whole energy management system at the transmission level, which is now going to be very uniquely challenged given where generation is going and given where the grid is transitioning. Today's transmission is more or less a radial transmission from point to point. If you're going to have alternate pathways as something that is an emerging reality of the future, over time, I do believe AI and ML technologies are going to play a very important role. And of course, I think Dr. Vadari, who's here with us, talked yesterday eloquently about that whole forecasting, that whole challenge from forecasting all the way to the settlement and the payment system. There is so much of opportunity there. And then you go to the distribution system of the future, and you talk about 250 million smart meters. The most valuable asset of the utility, I will bet you, is the data from the smart meters. And using that data from the smart meters, you can now use AI and ML technologies to actually do prediction on, real-time prediction on the situational awareness of the distribution grid, predictions around operating the distribution grid, things like fault detection, isolation, restoration, voltage VAR management. And think about the holy grail of a utility today. What is that? It is the fundamental network model at the utility, which is a geospatial model. The geospatial model has to be electrically correct, temporally correct, and geographically correct. And if you ask an average utility across the world today, how accurate is your geospatial model today, and even how far down do you go, the answer is we don't model end users and customers. We model up to the transformer, perhaps. Not everybody, but most. And at best, the model is 40% accurate. When you have a geospatial model that is 40% accurate, you cannot build those circuits in advanced distribution management systems, distributed energy resource management systems, outage management systems, because if you try to do that, and if you try to execute automation using fault detection, isolation, restoration algorithms, or adjusting voltages and things of that sort, there will be some massive blowback to that. You may kill people. Outage management is another story. I was telling the story yesterday about outage management, where the wonderful story of outage management is what? You got the AMI no power signal coming in. The first outage is a predicted outage. 5 or 10 more meters go. Then at that particular point, you cascade the outage up to the next level, and you do a predictor. And then you look for the SCADA signal coming in, and it becomes a confirmed outage. And then whether nested outage, then you start sending out people to fix the outage problem. Well, what if it's a storm like what happened in California, where the storm comes through in continuous waves, not just one wave like a hurricane. It just keeps on coming at you, day after day after day, 2 or 3 waves. And by the time you're done with the first wave and you start thinking about damage assessment, where again AI and ML could be applied very effectively, right, to improve your restoration cycle and reduce your outage durations and improve your service restoration, and most importantly, reduce your cost to serve. Well, guess what? Now, in this particular case, the outages kept happening. Their outage management system was not as smart because the geospatial system that it was dependent on was not fully accurate. And they had some other challenges as well. So I can foresee how the utility of the future would leverage AI and ML as you are unlike today when you had to put cuts and jumpers and go back and update your system. Maybe through the field, from the field, you make the updates and your geospatial system gets updated. And maybe you use AI and ML to keep that system up to date. And then you go one level beyond, and what is the biggest thing happening right now with respect to the impact of weather and climate change? The condition of your assets. Most of today's transformers and breakers are dumb. right? They are a mechanical device for the most part, windings and cooling systems and fans, but they are mechanical devices. So you can put the sensors and you can push the intelligence to the edge and put smart sensors on those transformers, not just DGA, but also overall total transformer monitoring on the transformer, total breaker monitoring on the breaker, and you can start getting intelligence from those sensor devices, and using AI and ML, you can do some level of intelligence at the edge and analytics at the edge, and you pull it back and do it in the headquarters, and a combination of the two. But that doesn't end there, does it? Because we haven't even talked about the most important person here that we talked about so much in this conference, the prosumer or the consumer. What are consumer behaviors? What is consumer looking from a utility today? We all know they want power and they want continuous power, so their phones keep the charge, right? This can't go. I don't mind if I lose water, but I cannot lose this, right? So what is the consumer of tomorrow thinking? What is in their mind? What do they want to do with respect to leveraging the opportunities that the utility may be able to provide to them, whereby the utility can provide additional services, improve their margins, create new alternate business models? How do you make those decisions on how those models could be created based on consumer usage data, consumer patterns, usage patterns, and the whole 9 yards? I call it pretty much usage data analytics, right? And beyond all of that, from an operational perspective, when it comes to blue sky, gray sky, and dark sky, the whole range of activities that utilities traditionally do before a storm, during a storm, and after the storm, AI and ML can dramatically improve their capabilities in terms of preparing for a storm, because AI and ML with weather data and non-utility data can help enhance the capability of the utility to actually predict and delegate resources to the right places based on where they believe the impact will be the highest, and when and how that impact will be felt by the utility and their end consumers. And not only that, once you're looking at the whole storm process that's going through, once the storm happens, you recover from the storm. We talked about outage, but storm restoration is an art and science in and of itself, and analytics, AI, ML can play a very important role. So across the life of a utility, I can see how AI, ML, and machine learning and other more modern tools, and I've not even touched the whole inspection space. I know that inspection is getting automated. Traditional utility inspection technique was LiDAR, human inspections. One utility that I know in North America spends $200 million on just manual inspections. Now imagine this. You have a combination of LiDAR, radar, and cameras. And of course, you still have your LiDAR. You're not going to get rid of LiDAR, but you have your cameras, you have your drones, and you have your other, quote-unquote, more intelligence inspection systems that basically looks at your substation, goes, is somebody coming to attack it physically or not, to shoot, possibly? Or is there going to be the condition of the transformer? You look at the camera and you start looking at heat recognition patterns, very much close to what we used to do in the industrial world in our racks, right? IR, right? Very simple IR technology, but leveraging AI and ML to figure that out and fix it, right? So across the board, we have a lot of challenges, and I can see AI and ML playing a very critical and an important role in leveraging and helping the utility become the utility of the future. So we have an esteemed panel. I just wanted to kick us off with some thoughts, and I'm sure, some of the folks are utilities and some of the folks are thought leaders and industry solution providers. So we hope that we can hear from each and every one of them. I ask that if you can each limit to about 5 minutes for your presentation, if you don't mind, 5 to 7 minutes, so we can have some time towards the end to not only have a discussion, but also, more importantly, get some feedback from the folks in the audience who are also, I'm sure, some of them are either working in the space or are genuinely interested in this space. So with that, I will kick us off.
We'll just want to invite one more speaker, Mr. Kuleshwar Sahu. He's a Senior General Manager from Power Grid. Sorry of missing you out. May I please request you to kindly take your seat? Please welcome him with a big round of applause. And now handing it back to session moderator.
So with that, I will start with Mr. Sanjay Prasad, Chief Information Officer of CESC, to share his thoughts with us. Thank you so much.
So thank you, Anand. And a very difficult session to negotiate, AI notwithstanding. So I will, in fact, Anand has sort of summarized for everybody. It's a very difficult task now to extrapolate on what has been already said. So what I'll try to do is I'll try to get some perspectives with respect to the business drivers vis-a-vis AI-led digital interventions. And then Anand spoke of, assets, customers, and environment, the storm reference that he gave. So I'm going to pick on one of them, which is the customer piece, the customer experience, and, try to share some of the experiences that we have had using AI ML tools. And thirdly, a very layperson's understanding of, the agenda talks about generative AI and a little layperson's understanding to share with you. So that's the composition. So, we have gone through, we are currently in what we typically call the utility 3.0. So, utility one was, the pensioner's paradise, where the consumer was taken for granted. And then with utility 2.0, a little bit of that unbundling happened between GT and D, but the consumer still remained captive, but he had some choice with respect to his service provider in certain jurisdictions. And obviously, utility 3.0 brings us to a point where, so that piece is still work in progress, but we have to be in readiness to see that the consumer is having that choice to move from, one utility to the other, whether it is, what we call as wire and supply. So it is important that utilities should also start thinking of themselves as a retailer, handling the last mile with the consumer and being the touch point. So since Anand talked about Walmart, going back past into my earlier experience, having worked with FMCG firms, it looked like Walmart at one end, actually touching the consumer interface, and with the levers, PNGs of the world at the other end. They had a stiff battle, between the two. So that's a learning for us, and therefore it is important to also change our mindset and see that we are able to bring in purposeful interventions that we do. Now, so keeping this context in mind, we speak of 4 drivers in a business context, and we say that it's driven by the 4 Ds, which is digitalization, decarbonization, decentralization, and de-risk. But it is underpinned by deregulation, which is on the anvil. So all this that we do need to take into account what's going to happen. So in terms of I'll keep digitalization, decarbonization, and decentralization as one piece. And it's not that nothing had happened earlier. IT-OT integration is very commonplace in the utility world. And sensors were in place, but this whole sensorization has happened, keeping both the decision making at the edge, which is the horizontal layer, and then making sure that you are able to encapsulate and aggregate and consolidate at I'll use a term that he used, at the headquarter level. He also touched upon the digital twin for the substation, which allows you to do a lot of network planning and limited amount of preventive maintenance in the future, and at the same time is a vital tool for your virtual training. And apart from that, on the generation side, you have the plant performance monitoring, so making PADO, which we call as an acronym, go to the next level. Drones for monitoring T&D assets, and obviously that's a given thing. And it also, in terms of capturing the data, there's not too much on AI on it, but optimizing the flight plan and making sure that you are able to catch the asset right on time based on past labeled data that you would have fed in is critical. That's where the AI-led intervention comes in. There are lots of other examples. I think there is a presentation from some of our colleagues on energy theft minimization using AI/ML in a big way. So while we all speak of this, there is a caveat that I wish to bring. Ultimately, in the Indian context, we also have to take into account that the hands and feet still need to work to manage the trenches and the overhead wires. So keeping that in mind, the counterbalancing that we need to do from a de-risk perspective, which is cyber security, is also critical in the Indian context. And we have seen earlier lip service used to be paid by the government, but now both Ministry of Power and Ministry of IT through CERT-In have become very serious in making sure that we just don't tick the boxes, but actually do what we are expected to do. And in doing so, the pandemic had not helped much because with the quadrupling of your endpoints, it became very difficult for security professionals to manage their setup. And that's where AI has made a big difference to be able to isolate the false positives and to completely change the narrative so that one is able to put their effort in resolving the right issues rather than chasing the needle in the haystack. While we speak of all this, I use the word purposeful use of AI-led digital interventions, and it has to be mindful. So one mantra that we all need to probably can keep in our mind is I use the acronym called PEACE. Peace as in war and peace. So Anand talked about three of them, which I mentioned earlier. Assets, customers, and environment. I'm adding two more, which is partner ecosystem, because nothing can be done alone, and you have to make sure that you have the right partner in place to take your initiative forwards. And the last piece is, of course, the employee, either permanent or contracted, because he or she is the channel through which these services happen. So if you are taking up any mindful absorption of AI-led intervention, make sure that at least two of these five, I call them pivots, get touched upon, and because either it should lead to operational efficiency or cost reduction, heightened customer experience, or simply improvement of process turnaround time. So, and of course, the biggest piece is revenue accretion if some of your projects do have that as part of the sign-off. So, in terms of when I talked about processes, one important part of processes is, we hear the term robotic process automation. That's been applied to utility processes in a big way. And now where does AI come in? Robotic process automation, while the word robotic sits there, but it's not fully, in a context of actual artificial intelligence being built in. So one is, we all hear of attended bots. So the next level is to see that can those attended bots, when the virtue of the term attended means that you have to be present, somebody has to attend, so you need a body. Can those then be used by voice commands? So that's where the whole area of NLP and NLU comes in. And then can bots be enabled to perform tasks in a hybrid workplace? That means where both humans and individuals exist. And therefore, these are elements of where AI-led interventions can come in. And the other thing is, not much success have been achieved with respect to imaging. That means you have an OCR. For 20 years, people have struggled to move from that 85% efficiency to 95%. And if you hit that, that's still almost like a gold standard. So through this labeled data that you push in, can these bots be enabled to really pick up those outliers and make this imaging efficiency much more amenable to process automation. Then the whole sort of chain from desk to desk gets fully automated, leaving the individual to do higher order tasks based on the MIs that gets generated. I will touch upon now. I'll touch upon the pivot called customer or consumer in our case, which of course anything that you do for them invariably touches any of the other two pivots. So if you look at the pyramid, the bottommost part is obviously delivery. You have to have consistent, reliable delivery in this case, and it's a given. Whether it is HTLT outage management, or whether it is how your repair times are kept on control. So once the delivery is done, the next stage is to bring in convenience, and most of the utilities have brought that convenience into the marketplace by way of reducing the footfalls in the customer relations centers and making sure that over time your chatbots, your WhatsApp bots got improved and are able to give a little more credence to the interface that you get to see when you click on them. The next level is when you is actually somewhere between experience and centricity, where moving from chatbots, WhatsApp bots, you talk about voice bots. And this is where we have been able to bring in a substantial difference in the consumer marketplace. Is we are arguably the first utility to have actually developed a digital voice assistant which complements the contact center, which is able to converse in Indian English, Hindi, and Bengali. So about 4 or 5 years back, I had this experience of trying out a POC, but those were early stages, while Alexa type English was past the technical POC, but that's something that you cannot try out with the consumers. So in doing so, we have been able to take certain cues of the call center where the anxiety levels of having a power outage or differing voltages, where the consumer need not have the credentials with him and is able to log in with his or her registered mobile number, bypass the IVR, and is able to converse with the voice assistant and either get a docket or get a predictive time by which the restoration is made in pretty good time instead of going through the maze of typically what we see in all call centers. So, and this took a lot of the P part here was very important, the partner ecosystem, while you're addressing the customer pivot. And believe me, we crossed all such possibilities. The biggies, the ISVs, voice technologists, startups, and even angel fund recommendees. So after doing that and getting them to do a regional language was itself very, very difficult. So speech to text, text to speech, using the whole array of asterisk call processing, SOX audio processing, and we were sort of able to bring it to a stage where years of data got fed in all the three languages, and we are still in the part of the journey we are trying to look at more complex cases which are getting addressed by this phenomenon. So, and one more thing, the other part, in case of a emergency where you are not able to sort of man your, I shouldn't use the word man, you are not able to staff your contact center or able to bring in those extra loads because of the emergency that is happening in and around because of an exigency, these play an important role to be able to handle that sudden surge in volume. So this is an example where we have been able to use AI/ML in a big way. And I'll just spend a minute or two in terms of the generative.
You're already at 13 minutes, sir.
I'll just take a couple of minutes because this is the good, bad, and the ugly. The generative AI, it's a term which I'm also a learner at this point of time. It emanated from, because the word existed in our agenda, so it's important that you spend a minute here, of 3.5, GPT 3.5, it's emanated from GPT 3.5, but it actually hails from the original GPT-3, and it is not something that has taken us by storm in the last 2 weeks. Way back during the pandemic in 2020, the GPT-3 was actually released, and which is 100x that of its previous version. But what is different from GPT-3 and Chat GPT that we are talking of is it has the capacity to interact with your satellite systems, your calling systems, so the level of integration is much higher, but its scale of interpretation is much lesser than what you would find in GPT. But one important point for utility OEMs, if they are here, the generative AI design helps utility OEMs to actually see their physical design right at the early stage, which can bring down the cost in terms of material, in terms of weight, and overall, compactness, and which in turn will give the utility a lot bang for the buck as these OEMs pass on the cost to us. At this point of time, I'll stop because he's really glaring at me, though I don't think I've taken as much time as he did. Thank you so much.
Thank you so much, sir. I think you brought up some very interesting aspects about the digital twin, and the piece was also very interesting. Thank you so much. So again, we have limited time here. The topic is very vast and very deep, and I'm sure utilities have done so much in this space. Just in the outage management space, so much has been accomplished. So with that, I'll ask Preetham. The rest of us, let's try to be respectful for the last speaker, and there's also a remote speaker as well. Try to keep it within 5 to 7 minutes, please. Okay? Thank you so much.
So I'll try not to repeat what has already been said. So I'll cover 3 quick points. Why AML, how to do AML effectively, because AML is just one piece of the larger jigsaw. The third is where in utilities to leverage AML, right? And that will probably overlap with the use cases that have already been said. Firstly, we have all been working with data. It's nothing new. We have in the past collected insights from the data, but we have been doing it manually. So what's different now is if you take the example of, say, anomaly detection in metering data or billing data. One way to do it is you compute the average, define what an anomaly should be, say it should be 1 sigma away from the mean or 2 sigmas away from the mean, and then collect the anomalies. That is one way. But with AML, what happens is you give the data to the machine, run an algorithm, and let machine determine or define what an anomaly is. That is very different from what was happening earlier, and that's what leads to efficiency at scale with automation of these tasks. And the data is there. It is from old ITC report. It's little dated, but I think it's still relevant. Electric utilities which have invested into AML will see their EBITDA go up by 20 to 30%, right? So that's the impact of AML. Now coming to how to run AML. AML is only as effective as the data it runs on. So for utilities, it's far more important or equally important to have a data strategy in place, overall end-to-end data pipeline in place before effectively running AML. Right? Right now, as we know, almost all Indian utilities have digitalized all areas of utility operations, be it corporate planning with ERPs, commercial operations with billing CRM, OT with SCADA, other automation systems, distribution automation, etc. And all these solutions have some kind of basic analytics or basic AI/ML running, but they are all point solutions. They just work on the data in their purview. They don't talk with other systems, right? But in order to effectively glean insights from the data that we have in all parts of the utility, it is absolutely essential to tie them all together, bring them into a common data lake, and then serve the analytics, serve the AML use cases for different users in the utility, right? So that is where I mean, most of the AML, I'll show you a slide, most of the AML in the world runs on AWS. So this has been the learning that this is as important as the models that you actually build on. Building on that, this is the data framework. Most of the terminology is AWS specific, but it is, I mean, the concept still remains the same. There are different systems from which the data has to be ingested. Ingestion can happen batch or real time. Different tools can bring the data into the curated. You can curate the data, put it into a data lake, and then serve them through the BI layer. If you see the right-hand corner bottom, that is where. That's a small piece in the entire data strategy. Now, where to leverage AML? Most of this has already been touched. So the primary drivers are the changing landscape of the utilities. There is a lot of renewables that are getting injected to predict the renewable generation and map it or match it with the demand. That is one area. Customer engagement, both the speakers have spoken. A lot of expectation changes from the customers. Customers expect, once the smart meters are installed, customers expect personalized messages with respect to energy efficiency or help them reduce the bills, etc. And asset planning and optimization, obviously a lot of predictive maintenance, etc. can be done. And that is one of the drivers that is leading to ML adoption. Revenue protection, I think my subsequent speakers will talk about it. And overall operational efficiency. Right. So these are a few use cases. One is computer vision based or audio language processing, customer care like chatbots, intelligent chatbots, or even voice assistants like Alexa. Then machine learning, energy delivery, asset optimization. All these have already been covered. And yeah, geospatial is one major area. Especially on use cases like vegetation management, etc., where AML can help look at the photographs and then tell whether certain tree or vegetation is coming in the way of transmission lines. And then finally, deep learning frameworks to enhance customer engagement, optimize trading or bid values in the open markets, and better DER management. So just a couple of use cases. This is what I said. I mean, more than 10,000 plus companies are running AML on AWS. 81% of all machine learning in the world happens on AWS. And finally, I think, Peugeot's Sound and Energy, which is a electric utility. They are using AML to improve the customer engagement rates, and they're using Amazon Forecast, which is one of the tools available on AWS for running forecasts without you having to build models. So that service itself iterates different models and comes up with the most suitable model for the use case. Similarly, Woodside is using AML for predictive maintenance and intelligent assets. And so it's running about 6,000 analytical models. And they are also going to the next level of using robotics for enabling the concept of intelligent analytics. I think with this, I'll conclude my talk and looking forward to hearing from you again.
So much, Preetham, I think very insightful in terms of what Amazon Web Services has got to offer. I do want to pass a comment on the whole EBITDA from a utility perspective, right? I think you can run the most advanced technology and algorithms and everything and show and demonstrate that here's where the losses are happening. But I think you don't actually save the money until the follow-up activity is done, right? So that's something I think it's worth, there has to be a political will to accomplish those tasks. So thank you. Thank you for keeping time. Really appreciate it. Luciano, sir, all yours.
Good afternoon, everyone. I think there is a few slides at my presentation. It's coming. Thank you. So we, as ISGAN, International Smart Grid Action Network, we have a dedicated working group on transmission and distribution. and that is like a system approach where we look to the evolution of the system, modernization of the system, and where all the digitalization aspects are considered, including artificial intelligence, of course. Today I will just go through the important aspect we are facing. These are the important discussion points for this session. I just remember that these are the topics we have to discuss today. And this is just to tell what you know very well, that we have a digitalization ongoing for the system. The system is becoming more and more complex. Yesterday we had a session on grid architecture that was very well received and interesting. In this case, there are some driving forces for digitalization. The system is becoming more and more complex. We have electrification of end uses. We have also decentralization, that means distributed energy resources, millions of them in the system. So you need a new tool in order to control, monitor, and make a better use of the system itself. So in this case, it's just some document that are from IRENA. In this case, you see where AI can be fruitfully utilized, span the whole system, from generation to transmission and distribution till consumption and end use. So there are several ways where artificial intelligence is now going to be implemented in the usual tool that the system operators are using. So we are moving from conventional tool to conventional tool powered by artificial intelligence. In this case, I was just going through the different aspects. Of course, when you want to integrate renewable, yesterday also we talked about the importance of forecasting. So artificial intelligence can really be one of the tools that can help to have a more accurate forecasting of the production from renewables. This is extremely important, especially when we talk about flexibility for the system. If you better forecast how much production you will have in the 24 or 27 or 72 hours from now, you can better understand how much flexibility you have to secure for your system, and this minimize the cost. Then, of course, there are other important aspects related to load forecasting, demand forecasting. So at the same time, you have to have both information available from the production and from the demand in order to make a better use of your system. But going through, you see how AI can be fruitfully utilized in other sectors. And of course, one important topic is like installing energy storage system. Also in this case, by AI, you can better decide which is the size, which are the performance, the ramping rate for this storage system to be used according to the size of the utility scale storage or is a customer side kilowatt-hour storage system. What else? Is important, of course, use AI to predict at best what is going to happen to your system in order to countermeasure whatever you need. And in this case, one important aspect that was also underlined by our colleague is to have a better insight about the customer and also to get to the customer engagement, because some of the clean energy transition that is happening right now is also very much depending on the social aspect and the behavioral change of the customer. For example, charging your car when there is plenty of energy, or this is also all the different behavior, all the different aspects can be better predicted by using tools based on artificial intelligence. What else? I think the previous speaker was mentioning the use cases. I think this is the basis. This is the most important part. It will be nice to really monitor and compare the different use cases to really understand which are the most viable, which are the most important, depending on the country, depending on the geography, depending if you are pay attention to a rural or urban network. But these are really the things we are caring about. So we are collecting this kind of list of use cases. We will be more than happy to exchange a view to understand if we miss maybe one important or we are considering exactly the same. This is quite important. One is of course still the integration of renewables and also the optimization of distributed energy resources. There are one slide just to tell you that there are many of these AI functionality to be used as a possibility for DSO. was distribution system operator for managing their distribution network at best. And this is not a very long list, but it's already a quite good list what they can use. For running the system, you can see here fault detection, you see forecasting, you see predictive models, and so on. These are really the important aspect that DSO are paying attention in these hours about using artificial intelligence. There are several also projects ongoing in Europe I am aware of. In that case, we want to really quantify which are the benefits that system operator can get by passing from conventional grid planning to grid planning by artificial intelligence. And the advantages is huge. Before concluding my short contribution, I would like just to mention that we, as ISGAN, have any year ISGAN Award. Last year award was celebrated in Pittsburgh, in the US. In that case, we have two different themes for the 2022 ISGAN Award. One was on electromobility, and the second one was on the just transition and inclusive transition. Maybe you can see that I was also in that picture with my friend, Dr. Reggie Kumar Pillai. But let's come to the 2023, this year award is exactly on artificial intelligence. We have the possibility to award the best project in the world about excellence on artificial intelligence. We are partnering with the Global Smart Energy Federation, and the submission deadline, unfortunately, is in 2 weeks from now, but we are also in a possibility to extend by a little bit this deadline. So if you are interested to submit your project, please do it. We will have an award ceremony on the 20th or 21st of July in Goa next to the G20. So we have also high visibility for this project to be granted. Usually we award the 3 projects, the winner, the runner-up, and the bronze medal, let's say. So 3 projects can be granted at the same time. Some other information about this is the theme for the who should apply. Everyone, in principle, utility, consortia, project that has been run. What is important that the project need to be up and running already at the end of 2022. You see here the focus of a competition with many topics related to artificial intelligence that matter with this award. Please consider this possibility, how to apply. There is a link where you can download it. This presentation will also be available to all participants. And if you need some additional information, you can also use the email. So we look forward to receive additional project in order to award the best quality project afterwards. Thank you so much for your time and your time. Thank you.
Grazie. It was a very insightful presentation from you, and I was very intrigued by looking at one of those slides where you talked about all the different applications. Like, we take it for granted, but the little things when you have renewables in the grid, things like direct transfer trip potentially to manage the influx of renewables and how to ensure overheating of the assets, voltage management, it was very interesting. And some more to say later, but thank you so much for your time, sir.
My pleasure.
Please join us. So now I'm going to ask, are we ready for Mr. Pandey? Please, Mr. Pandey, are you there? Hello?
Yes, I should be here if I am audible.
Yes, you may want to turn on, we want to get a bit closer to the speaker, sir. I'm not sure if the people in the back can hear you.
Okay, now how it is?
Very good, excellent. Muche ho to Nathuram ji jaise. Fantastic mustache. Very good. Welcome. Please take it 5 to 7 minutes and please share your thoughts. Welcome.
Okay, so let me try if I can share my screen as well, and that will be more impactful, hopefully. Are you able to see the slides now?
Yes, sir.
Yes, so again it is the next edition of this interesting event, and I'm very happy to be part of this. And I will try to highlight mostly some of the technological blocks and ecosystem, and some aspects which, when they will work together, they will create bigger impact. So once we will see the whole ecosystem, we have robots which can be of different shapes and different sizes, and with different kind of purpose in mind when they have been created. And basically they are able to act physically in the environment. So that is one of the capabilities we can have through robots. And then we have sensors, and that is also now becoming the part of the bigger system, which is IoT. So we can have different type of connected sensors sharing information. And then we have AI, and that is creating the ability to make decision or planning or even interpret the data, whatever is coming. So earlier, all these have been getting developed or working together, working in a isolated manner, but the trend has changed. Now they are coming together, and once they are coming together, they are creating the again the bigger ecosystem is having lots of other ingredients, but at least we can think about that we have mind, body, and sensing capabilities which are coming together. And in this way, we can think about lots of interesting application where we will need some physical presence, some decision making, as well as some kind of real-time situation assessment capabilities of the system. So this is something which is already happening now, and because all these technologies are coming together and they are coming faster than ever, we can again add blockchain, AR, VR, and digital twin, and what kind of communication technology which are evolving. So this is creating an ecosystem which has enormous potential. And we can think about lots of applications where human workload or even supplementing human abilities, and why not to reduce the risk and danger to the human, or also to reduce the error, human error. So this can be some of the drivers which we can think about when we are bringing technology in a domain or in a sector which was or which is already well established, but now trying to digest or ingest a new kind of technology. So we have to always think about what additional benefit or value this kind of technology can bring here. And again, it has lots of capabilities, including, I think we already talked about addressing, having, handling large amount of data or finding some patterns to optimize, or even addressing some, assessing some situation well in advance. So ideally, what we can think about is that this kind of system can also handle routine tasks and allowing people to focus on more critical tasks and even be more creative and more proactive at the same time. So I cannot touch the advancement of all the sectors in these few minutes, but just wanted to give the glimpse that sensors are already getting smarter, which are good for us, and then robots are already getting autonomous, and they are already having the ability to be teleoperated as well, and then having some kind of semi-autonomy if needed. So these different ranges or different ways of operating the robots will be also helpful to handle different kind of situation. And depending on if we want a robot to take decision by itself or there should be some human in the loop, the technology is now enabling all these different modes of operation from the robotics perspective. So now let me just summarize the applications. I think we have already discussed, and we have in the panel really companies, people, or organizations who are implementing these kind of solutions. So obviously we can think about inspection, cleaning, maintenance, then remote sensing, monitoring, and even we can think about a digital twin or mixed reality where we can train the staff, or we can operate from a remote place and perform the task in a more situated manner. And then we are already talking about generative AI, conversational AI, so they can be useful in different tasks and perhaps why not for the customer facing and assistance kind of application. But the key is that how we can make this kind of solutions sustainable beyond a proof of concept or a feasibility analysis or simply trying to show that, okay, there is a potential. We need to consider the bigger ecosystem, and there are challenges and there are requirements as well as there are opportunities. So we have to see the security safety aspect, the privacy and transparency aspect. In Europe, we are already working a lot on privacy and transparency, and I think this is the case now worldwide as well. And then the social and legal aspect and ethical aspect. And for all these, we need a collaborative ecosystem where people from different background disciplines should be coming together and create the right kind of environment and right kind of platform even to brainstorm. And that's where I think what we are doing today is a big step towards that. And then we have to think about how the liability and insurance can be considered, and then regulations which will be making integration of such technology part of the day-to-day life, funding opportunities, and then the bigger challenge is again the technological integration of different technology in a sustainable manner, both technically as well as from the applied side, applied perspective. And then we have to do evaluation and benchmarking as well. So that's what I wanted to say, that there are interesting opportunities and there is a way on which we have to move, and we have to move together. And once we will be able to achieve that, we will have lots of innovative solutions, and that will be good for us as humanity and also hopefully for the environment. And we have also launched a white paper on AI and robotics for utilities, so you are encouraged to also go through that. So with that, perhaps I can stop with this slide, and that technology should be seen as a kind of enabler for us to do things in the environment. And environment can be anything or any kind of application. We have to basically keep in mind what objective we are trying to achieve, and that will help in designing the right kind of solution, either it is robot or AI or the combination of those, or IoT or AR, VR, whatever we can think. We have to see why we are deploying this or why we are creating a solution, what is objective. Perhaps it is simply that we want to do things in a more meaningful manner, or we want to do things in a more impactful or sustainable or reliable or economical manner. But we have to at least think about those type of objectives which will derive the right kind of technology development and then the integration in the system or in the society. So thanks a lot. I will stop here. Okay.
Thank you so much, Mr. Pandey. Really appreciate your time. I've heard about mind, body, and soul, but it's the first time I heard about body, mind, and sensor. That you always learn something new. But we'll come back to you, sir. Sumit?
Okay.
Please go ahead. Please stay on, Mr. Pandey. We have some questions for you later. Sumit, again, 5 to 7 minutes, please. Huh? Yeah. We're running short of time, so.
Sure. Thank you, Mr. Anand. Thank you, Pandey ji, for setting the tone. And good afternoon, everybody. I know session after lunch are always heavy. I'll try to start my presentation with a case study. And what I'm going to show you over here is a real application of AI and machine learning in Indian context. Kyunki dil to hai Hindustani. Right? Now, AI and machine learning is like potatoes and onion. Everybody's talking about. My son, who is in class 6, also talks about AI machine learning at home. And he asked, Daddy, what you do? Which is going AI implementing in utilities. So, it's a simple thing which we're trying to bring out to the utilities. And can a presentation up, please? Yeah. So, okay. So that's where, now, that's where what I'm talking about is, this is a project with Ministry of Power. And you all know that 750 million household has been looked around as to be converted on smart meters in the next 10 years. 250 million has been put up as a target. And on that, the first phase of activity of smart meters have already been in order. The second phase of activity is yet to start, which is when the smart meters have been put in, what's going to happen next? How my things will start moving in, how my utilities will actually start looking in, utilizing them. And that's where revenue assurance, revenue protection becomes the key mantra, key challenge which is looking at. The ministry, the smart meters, something's burning. So I think the power-thon is gone, the ignition is put on. Anyway, so let's try to take I think it's all the safer side all, because we have fire brigade station nearby also. So just next to buildings, okay, not to worry about that. So the initiation is over here, and this is a project which has been done along with the Ministry of Power. There is an IIT Mumbai which is signed as an incubator. There is a utility called Jaipur Vidyut Vitran Nigam, right, which was picked up on. And there's a technology service provider, and then AWS as a cloud provider. Why AWS also I'll speak about. And this is a real essence of what happens in the real time when the data comes to us on fast-moving real time. How do you work upon it? Can you move to the next slide, please? Now, I want to touch upon the part of next slide. I don't have the control here with me. Oh, sorry. Yeah, okay. So what is that challenge in the utilities environment? What made this particular initiative to be put in? So when smart meters are being put in, like as a part of an RDSS scheme which is going on, then what will happen to the data, the large data which is coming up? Storing, monitoring, assessing, what is the usefulness of that? And when I go to utility, and when this project was initiated, the utility said, how I will actually make use of this data. Today, if you look around, utilities struggle to find out the cases of deviation of energy, theft, pilferages, bypass consumers, the service parallel consumers. And they said to me, this project will be successful, Mr. Gupta, if you can show us that live that point of time, if a customer hook, katiya marta hai, the hooks on my network in Bayana, this was done in a place called Bayana. So I should get to know this is the customer doing it so I can go and reach out to him. My dear friends, in 3 months, this has been done. So that's what the first part was. How can I leverage data from smart meters coming onto my environment where I have cloud to put the data in, and then I can do a real-time analytics to catch hold of those customers who are bypass, who are service parallel. The service bypass consumers are longer term of the hooking conditions which comes in. The second perspective, now in Indian context, my one set of consumers are smart meters. What about the other consumers? They will be put on a part of smart meters longer than next 10 years. Can I leave them? How can I get the efficiency from them? How can I really reduce the abnormality for them? Because I have to really maintain the billing. They also have been customer billed, and I have to look at part of how the data comes from their part. And the third, my dear friends, my smart meter will give me accuracy of billing. My non-smart meter how to get my perennial problem, revenue. How do I get my revenue faster, quicker, better, and within the time frame so I can get my cash flow? My maximization of revenue, I should find out where that's going to be looking at. And this is where was the aim of the part 2 of RDSS, which was piloted, my dear friend, under a name called Power-thon by Ministry of Power. And we were the top 3 people out of 500 contestants to be selected for that. And we did the state of Rajasthan in the place called Bayana. This is a city called Bayana. The mission of Mr. Modi to reduce bring the AT&C losses to 10 to 15% by means of Power-thon as an initiative to bring AI and machine learning adoption into that. Bayana as an area which is adjacent to the part of my friend Sanjay's territory, which is CSC's. In Bharatpur, this is a place which has a 36% of loss levels. Urban consumers, 49%. Just imagine. My friends from CSC also have an area called Malegaon where there are 68% loss levels. We did some pilot for them also. Now, this was a pilot area was selected out, and they said, if you can transform this is the case which comes for the India as a whole to be looked around. And my dear friends, the answers are there for you. This is the solution. First time in the history of India. First time. This is the first office pilot which has been done, which is being done for the AT&C loss reductions to enhance the revenue for the revenue protection, revenue assurance. And this encompasses a platform. These two are the platform, which is called RR Plus and the revenue recovery, which brings in the cloud live theft detections, billing accuracies of the consumers, and revenue recovery from both urban and rural, those consumers which are on smart meters to non-smart meters. This is what has been done, my dear friend. This is what has been done for 8,000 people who were smart meters consumers with 49% loss levels. They were smart meter, their data was looked on every 15 minutes interval with their event, and the load and event analysis was done to catch hold of the people who were hooking, who were pilfering, who was deviation of energy, and who were leaking of the part of the revenue for the consumers. The second part was the consumers, 40,000 consumers who are still non-smart meters. What to do with them? And they account for almost 40% of the revenue of the area. For that, there was a complete AI. My friend mentioned about the image modeling. How to use image? The meter image, which has been lying in that villages and the towns and area, look at those images and tell about which meter is being faulty, which meter is not functioning, where the readings are not being taken, and where in the meter readers are bypassing, they're not taking the reading at all. We catch hold of those. Those two areas you're seeing in second stage brought down the part of the changes. And the third, when billing has been enhanced, because I'm able to look at them, the revenue which has to be found out from the people, my dear friend over here, advanced machine learning models to learn about consumer behavior. It is good to predict, but changing the behavior of the person becomes important. We never change our lifetime behaviors, whatever we do, right? How can we expect to change the consumer behavior to start making payment early? This is where the behavioral, the genetic AI or generative AI comes into picture, which has been applied over in this place called Bayana. Bayana, which you start seeing in on the landscape of India map, because this is a project which will be inaugurated by Prime Minister Modi in the next month, which is coming up for them, my dear friends. Now, the impact of this project, it not only help utility to look at the part of indexing. Indexing, which was very important area, indexing was done with the live thing. It helped in terms of looking at the network flow right from the part of feeder, DT to the consumer. It also helped them to identify service parallel consumers, deviation of energy, pilferage point, and also look at part of the revenue recognition. Utility part of benefit. But then, my dear friend, we are talking about decarbonization. We're talking about the society impact. We're talking about how benefits are being passed on society. The people of the Bayana, they were more happy because they were not chased for the part of the faulty billing. They were getting the right billing to be done for them, and they have put a happy note to the MD of Discom that the transformation you can see, and that's where the society impact comes in. And my dear friend, not that. The decarbonization aspect in the small project which was brought in was a sustainable benefit. With the mobile and portal as a front end, the consumer are able to look at, make the payment. The consumer, the meter reader don't have to go to the household. Their fuel is saved. The energy is saved. The battery which has to be used for charging the devices, we are not to put onto this. 100 people are there, the meter reader, they're not devising charging now. Energy is saved. These small changes had made a sustainable impact to this project, my dear friends. And then, just finishing off, the key takeaways over here, the 11 lakh of the revenue which has been derived on the part of that billing inaccuracies. This place has 8 crores, which is almost $1 million of billing every month. My dear friends, 11 lakh, which has been there, $1,000 can be looked around part of coming in 115 US dollar. Look at part of the revenue which has been come from the part of billing inaccuracies. The second is bypass consumers, the theft, the smart meters. 40 lakhs, my dear friend. 40 lakhs has been tried to imagine in this 1 month. And then the revenue prediction of 1.2 crores was being recovered at 1.6 crores. $2 million have been recovered from there, which I think that 2 months, the AT&C loss level of the Bayana urban 49%, it has come down by 20%. That's the part of the story, my dear friends. We have done it. We have shown how to use AI and machine learning into the small place called Bayana, which has become a lifeline to go because a unique small. A small step a small step by a human being on a Mars led the transformation for the entire mankind. Same thing, a small unique done with the part of the Bayana, it has paved the way for the part of an RDSS transformation for the technology adoption. Thank you, my dear friends, and thank you for giving your time listening to me. Thanks.
Thank you.
So good afternoon, and thank you for giving me an opportunity. And as my eminent panelists have already discussed few of the use cases and how we can adopt AI and ML for the utility industry. Mr. Anand said a very nice phrase in the beginning, utility for the future. How we can use technology to build that utility for the future. So while we wait for the slides, the title of my slide says, Embrace AI in the Loop. So moving forward, there are a lot of scalability issues which are going to happen with respect to utilities because the demand is spiking up at a huge percentage, year by year. So there are a lot of, transformational changes happening with respect to a lot of demand coming into picture. There's a lot of EV adoption and there is a lot of load coming up on the grid. So how can we fix those things, or how can we improvise those things using AI? So one of those answers is embracing AI in the loop. Maybe not the complete answer, but one of the answers. Okay, yeah. So coming to technology and how industry has been adopting technology from a long time. We can see from 1900s all the way from 2020, close to 100 years. And technology has been involved or imbibed into the industry very rapidly. Right from 1940s, using hardware, software, microprocessors, and also when the internet boomed up in the late 90s and 20s. Also in 2010s, where we see a lot of big data, a lot of data being generated, by IoTs and sensors. But now the real question is, now when things have started blowing out of proportion with respect to AI and all the generative AI and ChatGPT and the GPT-3, how is that going to be helpful for the industry? So that is the main question, because we have to involve a lot of stakeholders, a lot of policies, a lot of regulations, and of course a lot of data. So how can AI as a technology empower and transform the industry and make it a huge revolution in the coming few decades? So just 2 to 3 case studies. I won't take much time as a productivity booster, because if you can see the slide, you can see there are a lot of components involved with the utilities or the discoms. There are a lot of asset things, a lot of policy changes, and these changes are happening very rapidly. So to keep in touch with all these things, we should not be following the old-fashioned way of downloading something from the internet and scrolling 10 pages of PDF just to understand what's happening there, because there's not much time. And things are changing very rapidly. And the pandemic was one example where things were blown out of proportion in a lot of ways, and it hit a lot of industries. So one of those use cases where generative AI can come into picture is when we can use conversational AIs to empower people working in the industry in such a way that they can have a conversation and get some more details of what they want to do and get timely updates and interact in a human form and try to get more information and insights rather than do all the human effort by themselves. And this is going to save a lot of time and energy. The next is gap filler. We have a lot of use cases around here. One of those is imagery-based risk detection and pole health detection. And this is our in-house developed conversational AI called Power Cognito, where we can summon the chatbot to generate images, novel images. These images doesn't exist, so these have been generated. And we can use this to form data sets and try to build AI algorithms and applications where it is going to reduce the time drastically. Imagine a person going around a field of acres together trying to understand where there might be a risk to the utility poles. Suppose a tree is growing rapidly and the pole breaks down, so there is a huge loss there. So for a preventive maintenance standpoint, we can use AI ML and train efficient models, have drones running over, try to identify the risk and mitigate them very soon. This is one of the, so the next use case is to create scenarios. This is mainly from the utility standpoint where things are rapidly changing. You want to manage your grid, you want to manage your assets, transformers, want to do preventive maintenance, which can save potentially a lot of money and effort. So to do that, again, I'll show a demo of where we have built this conversational AI, which will enable utilities to run simulation softwares in a natural language way. So the good old days of having something in Excel sheets, a lot of configurations, we have to employ a team to sit down, discuss, build the model, simulate, and fetch results. But now all these things can be done in a matter of minutes or maybe even seconds also. So you can see, you can create feeder test models, and the person can go and edit few things and say, okay, I want these things to be changed. Can you run me a simulation? So once we can, fetch the results of the simulation, we can also interact with the results, see, okay, what was the output, and then again continue conversing, saying, okay, I have this results. What will happen? What will be the impact if I add a few more, EV charging stations for my substation? So will that make an impact? Yes, but the amount of time required for a human to correct those things and go back and run it again is a lot harder and time consuming. So again, here generative AI tools and conversational AI can help a lot in this regard also. I have a demo for you. Can you please the demo? Yeah. The short clip. Yeah, so this is the chatbot what we have developed in-house, and if you can play it. Yeah, so here this chatbot can do text to simulation, basically is text to sim. So whatever is conversed in a textual manner, it can interpret the intents, entities, and try to run a grid lab D simulation. So it just asked me, I can run simulations, how can I help you? I can, give me some basic values to start with. So I'm typing, okay, the number of feeders are this, I have to give the number of buildings, power rating, and in this scenario, spelling mistakes, grammatical errors are taken care by the AI itself. So not much of training, involved, or too much of training required for people to adopt this technology also. You can just speak to it as if you're speaking to a human. So right now I'm typing, okay, the location is Delhi. I can give the name of the node. I have mentioned the number of LV feeders. And over time, it is going to understand what I want to run, and it is going to simulate and fetch the results for me. So this is how we can use conversational AI to accelerate our development, to accelerate the productivity in terms of from the utilities. So we can also develop solutions for the customer centric also. What was my bill last month? I attended the master classes few days back, and one person was saying, okay, how can I enable the user to save more on his electricity price just by conversations? And we can see now that here are the results. I can interact with, in a graph format. So this has, this will drastically reduce the development time and effort required to run something like this. So this is one of those applications we are currently focused on, but there are a lot of AI/ML applications. As a few of my panelists said, there are a lot of storm outage predictions. So we don't want to be limited with just weather. We want to take satellite imagery, weather conditions, a history of past weather, how the transformer is working, what is its current status, and then aggregate that information and try to make a informed choice, which will save again a lot of time and effort. So all these applications coming out from transformers or generative AI more or less want to focus on optimization and saving of resources, so that the acceleration or the development can go in an exponential way rather than in a linear way. So few more applications for monitoring, edge processing, outage predictions, disaggregation. A lot of resiliency, optimizations can be done using AI and ML. And considering the scale of data we are working with, terabytes and petabytes of data being generated from sensors all across the globe. And as Sumit mentioned, a lot of smart meters also being rolled out. So now is the time, to embrace AI, and I'm sure that this is a great forum to come across and discuss with the government, utilities, key stakeholders who are all committed to make this a big event and transform the industry in a big way. So I'd like to thank you for the time. And
thank you so much, Pranav. Really appreciate it.
Yeah.
It was very insightful, actually. Thank you so much. Krishna?
Thank you, everyone. My name is Khurshid Khan from BSE's Rajdhani Power Limited. So, thank you to give the opportunities to speak on the technologies here. So, let me slides, please. So, as you can see here, this is the tremendous growth is going on in our technologies here. So you can see in the futures, this is the area of mechanical economy. So we say that because of in our last decade, so that is we are just learning about that going digitals as GST, demonetization, many more things. Now, this decade we are the going smarter now. And as per the details, we can see from some publications, we find out that solution here, that the 70% of GDP will be growth in our means China and Indians area, our global levels. It is for the AI, ML and technologies. And also till 2030, so that is $15.7 trillion will be the economics of the growth in China and India's only. So we can understand this. It's a very tremendous growth is going on because of our technologies. So here's we can. So there is some basic information of our artificial intelligences, machine learning, robotics, and generative AI. So I know that everyone know about that technologies, and just a brief is giving here that the AI is just giving the human-like behaviors, thinkings, and so that he can take decision makings. Where the ML, machine learning, is just giving a trainings to the machines to improve the task in a perfect manners, and it can itself learnings improvement on the experience and trainings anymore. So the robotics is a part of, this is the era of that robotics, and we are using means lot of means improvement in that area. So it's just an automations and operations and just creating some new technologies and like the drones and including the AI and machine learning. So this is a combinations of all the technologies in between, and we are working with for the utilities. It's a means very important role and significant role in here. And generative AI it's a means amazing technologies where we can give a means a mirror of the physical assets, and we can test it. We can our engineers and our means technicians can work on that imaginary means real time behaviors of that means equipment. So, because of the time up right now, so that's why I have to skip some of the details where I am putting here. And for the utilities, there is where there is many areas where AI, ML, robotics, and generative AIs can be worked for. So I'm just skipping that the slides there, and you can see here there is many areas, and it's hard to see that. So there is many applications where in the utilities applications where we like the predictive maintenance, and where we can AI and MLs can identify the area of the faults, and it can give you the benefits to fastly recover or repairs and give the maintenance productive. So grid maintenance and the energy efficiency is very important to means the consumers' behaviors, and and you can learn about that, and the systems can learn and give the benefits how the consumers can reduce their power consumption. So there is many areas that customer services that that voice bot and chat bot as well, and personalizations where we can understand that AI and ML can give some suggestions to consumers to reduce by studying of their history and their uses of that power and behavior of the payments, behavior of means how they are means working with that utilities. So it's that being learned, and it's being just personalized to give the give the suggestions to consumers. So there is many parts of that. I'm just skipping of them, these areas. You can see that technologies for the AI and new technologies like that. We are moving now the smart grid and grid securities as well. So many areas that we can work. And it's just in potentials and now I'm just going to be, means what actually BSES is working and what initiative on that technologies because of the BSES Rajdhani Power and BSES Yamuna Power Limited is committed to give the uninterrupted powers to capital of India. So we have done some initiatives so that one of them is the predictive maintenance, that is the AI-based predictive maintenance. We are means associated with the vendor, Vidarna, and it's a utility. It has have an application that is vSense. So vSense is nothing but is a provide the facilities to identify the faults, identify the means high power resolutions, image and videos. He can recognize the 100 types of conditions of that your assets. Like we have done in pilot project here, and 28 of our HES, EHV towers and our grid substations. So approximate 28 we have completed, and where the drone is just generating the high power, means high resolutions images, and that is being uploaded in the vSense applications. That is software is itself identifies all the criterias and the necessities of like it has means where is the fault, if there is any fault, is there in the means cleaning and face to face the ground level of cleaning is there or not, means 100 type of conditions are there. So it can be give the predictions to the consumers, to the company that he can identify and can give the timely analytics of that. And so there is very lot of benefits we have on this. And one of that, like I given an example. So one of the means use cases of this, like there is a tree and some grasses are there. So it's automatically by bio properties it's checked of that assets and see that means at this time this will need to be means clean. So such type of intelligence is built by the AIs and machine learnings. So next we have a pilot, again pilot that is a behavior energy efficiency. That is actually the personalized sense, and you can say the means energy forecastings to the consumers so that it can some intelligences. We use the means Oracle's products with O-Power. So O-Power is just reading all the data of the consumers and take the like the behaviors, their efficiencies, their how they are means giving the energy and their lifestyle of this. So it's calculate and give a give the predictions so that it can means the consumers can take a proper decisions on it, and he can reduce their power consumption. So we tested it with the 2 lakhs of consumers, and we find means very good result on this. They have reduced the 32% of means power consumptions they have. So and this is the Alexa. So it's very easy to means we have integrated that with our systems, and means any consumers will just say the Alexa and let me know the last bill of my and the last 5 bills and what information he can give. So we have just added some 6 items on this, and many more we are just going to be improved. Another one is this power chatbot. So I don't think this need to be introduced. That is, but this is the means 17, 20 items that the informations can be taken very easily by the mobiles, and the consumers is happy with it to not to ask our means service centers. He just put the numbers and then get the immediate information. So it's a very fast and very consumer service is very good. So next one is our data lake. So BSS is creating the data lakes. It's in pilot projects we have done with the Greenbirds. It's a Norway-based company. So here we integrated means that the means data lake what actually is. So there is various departments, various servers, various type of data we have, and every data is being means maintained by their own service owners. So why this means? Because of if we go to the assets, so asset is being used by some in our inventories, and the billings data is separate, and many hardware and equipments readings and powers data is. So the data lake is just combining all the information in the centralized storage locations. So it's a centralized repository where we put all the associated data in that, and so that we can do on this machine learnings, artificial intelligences, and interconnections with that data, so that we can find out some the results that can give us a better way. So here we have added many data here, and also we got the gold award in this in the same form, IGF. And you can see that the asset you can represent in the graphical manner. So it's a geolocations where our grids is associated with the different data, means DTs.
Sir,
and DT is integrated.
Yeah, it's already 12 minutes.
Oh, just going.
No, you're done. I'm serious. We have to stop now. We have to stop because we are out of time and the next session is going to start.
Oh, okay.
Sorry, okay?
Okay, this one. Wait. So the virtual realities, that is because of improper operations, so had given the virtual realities provided, and the training sessions we are giving to reduce the fault, and so because of 32% is the fault is because of the improper operations and improper training. So that the virtual reality trainings we has given here, and it's digital twins. That is, we have done as a pilot here, and so that we can organize the real-time power supplies, energy, and so that it can be utilized for our testings and our data. And thank you very much.
Thank you, Mr. Anand and co-panelists. I will not take much time because time is already up. We PowerGate is the largest transmission utility. We have transmission asset 2.9 lakhs more than tower is there. We have substation equipment, they are counting 1.67 lakhs. So huge asset managing is manually not possible. I will talk about one is the transmission line inspection and other is substation. Transmission line inspection, we have two things. We have a tower inspection and second is vegetation management. And I'm happy to share you, we have developed something machine algorithm for defect identification, what are the photo we have captured. We have inbuilt software is there. So whenever our person is going for inspection, they take the photograph and through machine learning, all the defect photograph is categorized. On the basis of defect, we plan the maintenance. Another is vegetation management. For vegetation management, we are presently using the LiDAR technique through the drone. And in coming future, we may also think about how to control this vegetation through the satellite. So this is the thing. And third one, gray point for power grid is because drone has a limited flying time is there. So we are also searching for something robotics, which self-powered. It can be crossed from end point to last point with all type of LiDAR and thermal cameras, so we can detect all things. So this is one of the desire for robotics
in the market. Another one is substation equipment. We have a HVDC, 800 plus HVDC, they are carrying 6,000 megawatt. We have a various 765 bus system is there. So now, how to manage this large asset? So now we have a SAP data is there. So we are creating a health index for each and every equipment. For like all transformer, reactor, breakers, like Mr. Anand has said, we have a, suppose one transformer, it is feeding the power, suppose capacity is 90% is feeding the power. And very critical loads, it is feeding. Another transformer is, suppose it is a capacity is high, but it is feeding low priority area. So through health indexing, we can create, optimize our maintenance plan also. So we are looking for the health indexing models available in the market, and also we want to have a degradation curve. And on the basis of this, we can go for the, what is the effective age my asset is there. On the behavioral effective age, now what will be the impact of the failure of those equipment to the system. So besides this, all these categories not possible manually. So definitely AI ML is a way to get all this data is there, and on the basis of this, we can plan our asset maintenance plan will be there. Another is inventory management, because Power Grid is more than 2,000 crore inventory we have also. So we are also using this AI ML technique, which equipment, which component is much failure rate and which is less. So accordingly, we can manage our inventory asset. Another one is AR, VR also. Power Grid also, we have also purchased something, virtual digital headgear system is there, and we are using those for remote assistance training program for this purpose. I think time is up, so I have a lot of things to talk, but I think just thanks for my seat. Thank you.
The panelists, I really think that the time that we had was very short for such a vast topic and of significant value across the value chain. And I think it's very appropriate that we got opened by CESC and closed by Power Grid. I mean, you cannot think of two vital utilities, in this country than CESC and other utilities in BSES Yamuna and Power Grids, right? And in the middle, we heard from many experts who are working in the space and the technology. I'd like to sign off with this one thing that I've always believed. In that whole people, process, and technology chain, I've always believed people are number one. People, the worker, right? The utility worker who is really a face in the crowd, right? They're doing so much during the day to keep lights on and keep power on for people. They go through a lot to do what they do for us. They're almost like a frontline worker, right? But as I'm watching this digitalization and the digital transformation going through, working with one particular utility, what I found out is that the biggest resistance to change is from where? Is from the ground up. Why? Because they believe that they have done things a certain way until now, whether it be a tester or a lineman or an engineer, right? While there is support from executive level, right, there is a lot of resistance. Why? Not because they don't want to change, because they fundamentally, they have seen and done, a typical example is a substation. When you take a test switches and you test, you're seeing the result of that test. If in a digitalization situation, you don't see the actual result, right? So that has been the challenge that the whole digitalization is going to pose. It's going to be a fundamental paradigm change for the worker. And I think change management, worker training, worker participation, and motivation is going to make the difference between success and failure in this process of digitalization, and AI, ML is no different. I really would like to have had time for Q&A, but as I said, it's a very vast topic. Our panelists have done their best to stay on time, but it's a very vast topic and a very deep topic, and a lot of the utilities have done a lot of good work on that, and I just wish that we can follow up with this and maybe have individual sessions where each of those success stories that Sir talked about and we heard from BSCS and you, Sir, as well, can be elaborated more and we can learn more and do some hands-on exercises as well. With that, I will sign off. Let's give a big hand to our panelists. Thank you so much. And I will end with that. Thank you so much. Have a good one.
Thank you, Mr. Venkateshwaran, for spearheading the discussions for this session as session moderator. And in your capacity as session moderator, may I request you to kindly do the honors of presenting the mementos to all our speakers. If we can start from this side, so please come forward. And may I now invite Mr. Anand Singh from ISGF to please join us on stage, and requesting him to do the honors in presenting the memento to our session moderator, Mr. Venkateshwaran. Can we request everybody to come forward for a group photograph?